This is my simple harmonic motion test corrections for parts A, B, C, D, and E. So for A, I did not lose any points, but for B, I lost 2 points. So the first point that I lost was that acceleration needed to be between 9 and 11 meters per second squared, but my handwriting was not that good. So it didn't look like it was within that range, but it was actually within that range. So what I did was that I did the mass times acceleration equals the kinetic, the spring force of the spring times the distance, the maximum distance that the spring oscillates from. So the maximum acceleration would be the absolute value of k times x max divided by the mass of the object, and then that would equal 5.12 times 0.25 meters divided by 0.125 kilograms, and that will give you 10.42 meters per second squared. So that is what I meant to put. The next point that I lost on part B was that my acceleration graph was not a sinusoidal, or however you say that. So here is the graph, and these are the timestamps. 2.5 over there. So what I did was that it was kind of like a linear graph, but it should have been curved at the edges. So it should have been like this. 0.51 seconds on and on and on. Oh, no, 1 second, 1.5 second. And then the way it was supposed to go, it was like this. Oh shoot, like this. Like that. What I did was just like a straight, which is wrong, because the force increases exponentially as it reaches its maximum amplitude, and the acceleration would slow down because the force being applied on it would reach its greatest, and it wouldn't accelerate as fast. So for part C, I lost points because I did not include measurements that are needed to be done, and I did not include a diagram in the open spot in the top right corner, and then I did not have evidence of multiple trials for each weight. So in my original explanation, I said that the student would need all the materials, and then I said how the student would need to set up the materials. I then said what the student needs to find, but I only did that for the height and the change in distance from the equilibrium. And then I went on to say how to find the total energy of the system to see if it matches like a spring, and that's where I lost the 3 points. So what I would need to do to get those points is that my explanation would need to be basically a student would need a lab stand, meter stick, rubber band, and a set of 100-gram weights. and then the point that I lost, it would say the values that need to be measured are the weight used in kgs, the equilibrium point, which would be in meters, the change from equilibrium, which would be in meters, and then the force on the rubber band, which would be in newtons. And then I would go on to say the setup. And then after that, I would explain that for each trial, multiple demonstrations would be needed for each singular weight to reduce the percent error. And that's it. That's all the points. Oh, and then I'm missing the diagram, which would just be the lab stand. Where's it at? It'll be the lab stand, and then a hook or something on the side, and the rubber band would hang on it. And this is another hook with the weights. This would be equilibrium. This would be the new equilibrium. These are the weights. And they change. This is the lab stand. This is the rubber band. And then you need a ruler. Oh, that's what I was missing. You need a ruler for the materials. I forgot to say for the last part as well, for part B of corrections, I will post a picture of my notes at the end of this video for each section, because I can't take a picture right now because the quality is bad. This is part C. This is part D of the explanation, corrections. So I lost all the points for part D because I did not understand how to find the values that we needed to do for this experiment. So what I said, using the K value found in the experiment, plug in the different stretch values and the K value into the equation F of spring equals K times the absolute value of X for both the rubber band and the spring. If the X distance is the same and the K value of the spring and rubber band is the same, the restoring force will be equal. That is completely wrong, because this is asking how should the rubber band act if it were to be an ideal spring. So what you were supposed to say, or what my explanation was supposed to be, was that first, there should be a linear relationship between the force and the mass of the rubber band stretch. So what we would say is if the rubber band is a ideal spring, there should be a linear relationship between the force exerted by the rubber band and the weight being hanged for every single weight. And then I lost a point because I did not specifically say that the graph should have a linear relationship if it were to act like a spring. So if the graph is linear, then the rubber band acts like an ideal spring. And then for the last part, I need to say that it needs to be a straight line, and then F should be proportional to X, like a spring. So F would be K times X, once you find the K of X, and then it should be proportional to the different types of mass. So the line should be straight when comparing the force, which is the force of the spring, which is equal to K times X, which straight line when comparing the force of K of X to the y-axis of the different, you would switch that. This would be the x-axis, this would be the y-axis of the different weights being used. The notes for this problem will be at the end of this video. This is my last set of corrections for the harmonic test. This is part C. So I lost points because I did not include multiple trials for the each weight, because I did not include different weights. And then I did not have a legible diagram and graph, which was partially because I did not understand. And then the last point was for the APP1, when the teacher gives you, I think it was the test, before in the actual test, you should try it out and then come during before class and try it out with the teacher. So to get all the points, you would have done a chart. So the first would be trials, or it would be weights. And I believe it was, let's see, 100 G's, and then this would be trials. So you would have trial 1, trial 2, trial 3, dang, 200 Gs, trial 1, trial 2, trial 3, etc. And then what you would do is for every single trial, you would find the change in distance from equilibrium. And after that, change in distance from equilibrium, and then after that you would find the total force at the max point at x max, which would be your mass times gravity times height, which would give you your total force, so mgh, which h would be the distance from equilibrium. Once you find that, you would plug this in to solve for k, which would equal, let's see, it will be 1/2 x squared divided by ug. And once you do that, you would get your k value, and then for every single weight you would do it, you would average it for 1, 2, 3 for each single weight. And once you do that, you would just plug it in into the chart. So the chart would look like this, and it would have the weights, different weights, and then it would have the force of the spring average for every single weight at the max distance. So like bang, 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 bang. This would be 0.01, 0.02, 3, 4, 5 meters. And then this is 100 grams, 200, 300, 400. And it should increase proportionately. So it will be 0, 0, and then let's say it should go like this in a straight line, proportion. And then the last point was APP1. When the teacher gives you access to a test, the smartest decision is to access it, try it out for yourself, come in the next morning, and then check it out with the teacher. The notes will be posted at the end of this segment. That is my simple harmonic motions test corrections.